Hello everyone, today my team and I will be explaining about the topic integration. So at first I would like to thank my lecturer for giving this opportunity, and now we will be starting with our group members introduction. Hello everyone, my name is DUVENTHIREN, son of Lakshmayogendran, and my registration number is 01 DKM20F1065, and I'm from DKM2B. And here this is my picture, this is how do I look. Next, my friends will be introducing themselves.
Hello Madam Lim, I am LISHVAARAJ Naidu Analaki Sivaji Selvan. This is how I look. My registration number is 01DKM20F1066, and as you know, my class is DKM2B. Thank you, Madam.
Hello guys, my name is INESH, son of Ravi. My registration number is 01DKM20F1041. I'm from class DKM2B as well, and this is a picture of me which you guys can see.
Okay guys, now let's start our introduction for our topic today. An integral assigns numbers to functions in a way that describes displacement, area, volume, and other concepts that arise by combining infinitesimal data. The process of finding integrals is called integration. Along with differentiation, integration is a fundamental, essential operation of calculus and serves as a tool to solve problems in mathematics and physics involving the area of an arbitrary shape, the length of a curve, and the volume of a solid, among others.
Hello Madam Liu, I am LISHVAARAJ, going to present about the question given for presentation. I will be discussing about question A. There is a graph given for this question. This is the graph. Question that I get is I need to find the coordinates for point A and B from the graph given. We know that the equation of the curve given is y equals to x squared minus 4x plus 5, and the equation given for the straight line is y equals to 3 over 2x plus 5. Using these informations given, we have to find a solution to get the coordinates for A and B. So now, let's get into the question. First of all, we need to find the coordinates for point A. Step 1 is, we need to substitute the equation of straight line, which is y equals to 3 over 2x plus 5, into the equation of the curve, which is y equals to x squared minus 4x plus 5. By doing this, we will get equation at the both sides, which is 3 over 2x plus 5 equals to x squared minus 4x plus 5. Next, we have to turn the equation above into a quadratic equation, which is the equation must be equals to 0. So, we need to take the 3 over 2x plus 5, bring it to the other side. By bringing those values to the other side, positive 3 over 2x will be negative 3 over 2x, and positive 5 will turn into negative 5. By doing this, we will get an equation of x squared minus 4x minus 3 over 2x plus 5 minus 5 equals to 0. So, we have to solve the equation, and as an final result, we will get an equation which is x squared minus 11 over 2x equals to 0. By using this, we have to continue with our step 2 and 3. Since we are done with the step 1 in the previous slide, now it's time for us to move on to step 2. In step 2, we will need to find the x values from the previous slide equation that we found, which is x square minus 11 over 2x equals to 0. We need to press this in the calculator and find the 2x values. The 2x values I've get is x is equals to 11 over 2 and x is equals to 0. From here, we need to move to the third step. In third step, we really need the equation of the curve, which is y is equals to x square minus 4x plus 5. We need to use this to substitute the x values into them. When x is equals to 11 over 2, we need to use this and substitute them into the curve equation like this. So y will be equals to bracket 11 over 2 square minus 4 bracket 11 over 2 plus 5. The value of y we will get is 53 over 4. We need to do the same thing for the second x value, which is x is equals to 0. We need to substitute the 0 into the x values, where it will become like y is equals to bracket 0 square minus 4 bracket 0 plus 5, and the y value we get here is y is equals to 5. From this, we know that the coordinates A is 11 over 2, 53 over 4 in fraction, or 5.5, 13.25 in decimals. Okay, in the previous slides, we have successfully found the coordinates for A. So it's time for us to go to the step 4, which is to find the coordinates B. In step 4, we will be able to find the y value of B. This is because it is already given in the graph. As we can see, the B lies on the line. On this line, we can determine that y is equals to 0. Since we have found the y value and our next step is to find the x value, we will jump to the step 5, which is finding the x value by using the equation of straight line given. In the equation of straight line, which is y is equals to 3 over 2x plus y, we have to substitute the y value, which is equals to 0. So we will get the equation like this: 0 equals to 3 over 2x plus 5. From this equation, we need to make the x as the subject. So we have to move the positive 5 to the other side and the 3 over 2 to the other side as well. So we will get an equation of x is equals to negative 5 divided by 3 over 2. The x value will be negative 10 over 3. Since we have already found the x value, now it's time for us to tell the coordinates for B. The coordinates for B will be negative 10 over 3 and 0 in fraction, or we can even say that it is negative 3.33 and 0 in decimals. So we already found the answer for coordinate A and coordinate B. I've done with my question, and now I will give this presentation to be continued by INESH. Thank you.
Hi guys, it's me again, Inesh. Thank you Lishva for explaining question A. So now I'll be explaining to you guys how to obtain the answer for question B and bring you to the step-by-step methods and process. So first, let's look at the question. Question B is, find the volume of the solid formed when the bounded area to 360 degrees about x-axis. So we can obtain this by using the formula volume equals to V1 minus V2. So when you notice at the question, there's two equations which can be used. So our V1 will be volume below, which is 302x plus 5, and our V2 will be volume above, which is y equals to x square minus 4x plus 5. Okay guys, so now we'll be doing our step 1, which is getting V1. So V1 can be obtained by using pi integral a to b y square dx. So since our y hasn't been squared, now we'll square our equation. So y equals to 3 over 2x plus 5. Once we square the equation, we'll be getting y square equals to 9 over 4x square plus 15x plus 25. Now we can obtain the value for v1 by substituting the y2 that we got. So v1 equals to pi integral 11 over 2 to 0 bracket 9 over 4 x square plus 15x plus 25 dx. So pi bracket 9x cube over 12 plus 15x square over 2 plus 25x closed by upper limit 11 over 2 and 0. Now we'll be replacing our upper limit and lower limit into the equation and we'll obtain pi bracket 3993 over 32 plus 1815 over 8 plus 275 over 2 minus 0. Now the value for v1 is 15,653 over 32 pi unit cube. Now that we've obtained our v1, we can get our v2 as well using the same method, which is the formula pi integral b to a y square dx. Now just like v1, we should get the y square for this equation, so y equals to x square minus 4x plus 5. Once we've squared this equation, we obtain y square equals to x to the power of 4 minus 8x cubed plus 26x square minus 40x plus 25. Now that we've obtained our answer for y square, we can substitute it into the formula and get the answer for v2. So v2 equals to pi integral 11 over 2 to 0 bracket x to the power of 4 minus 8x cubed plus 26x square minus 40x plus 25 dx. So pi bracket x to the power of 5 over 5 minus 8x to the power of 4 over 4 plus 26x cubed over 3 minus 40x square over 2 plus 25x closed by upper limits 11 over 2 and lower limit 0. So now we'll place it into the equation and we'll obtain pi bracket 1006.57 minus 1830.125 plus 1441.916 minus 605 plus 275 over 2. So the answer that we got for v2 is 150.861 pi unit cube. So guys, since we obtained our answers for v1 and v2, now we can obtain the answer for our question, which is volume of the solid formed when the bounded area through 360 degrees about x-axis, using the formula v equals to v1 minus v2. So since we got our v1 and v2, we can substitute it into the formula, which is v equals to 15653 pi minus 150.861 pi. So our final answer is 338.30 pi unit cube. This is the answer for question B. Thank you.
Thank you LISHVAARAJ and INESH for explaining the questions above clearly and in detail. Hope everyone understands it very well. Now we are in the last part of this presentation. So now we will be looking at application of integration in real life. Integration has been applied in many kinds of aspects, such as in engineering, physics, and also in statistics. First, we look at application of integration in engineering. In architectural engineering, an architect engineer uses integration in determining the amount of the necessary materials to construct curved shape constructions and also to measure the weight of that structure. calculus is used to improve the architecture not only of the buildings but also of the important infrastructures such as bridges. As an example, building dome over a sports arena, building our nation's pride Petronas Twin Tower, and also building the second longest bridge in Southeast Asia, which is Sultan Abdul Halim Muazzam Shah Bridge, which is also known as Penang's second bridge, needs calculus to be applied, which is integration, to get the precise amount of the necessary materials to construct and measure the weight of the structure. Next, in electrical engineering, integration is used to determine the exact length of power cable needed to connect two substations which are miles away from each other. Then in aerospace engineering, spaceflight engineers frequently use calculus when planning for long missions. To launch an exploratory probe, they must consider the different orbiting velocities of the Earth and the planet the probe is targeted for, as well as other gravitational influences like the Sun and the Moon also. Okay, next is application in physics. In physics, integration is very much needed. For example, to calculate the center of mass, center of gravity, and also mass moment of inertia of a sports utility vehicle. The last one will be application in statistics. Statisticians will use calculus to evaluate survey data to help develop business plans for different companies, because a survey involves many different questions with a range of possible answers. Calculus allows a more accurate prediction for the appropriate action. That's it for the application of integration in real life. Thank you. Now, we will be ending our presentation by giving credits to my team members LISHVAARAJ, INESH, and myself DUVENTHIREN. And we would like to thank our engineering mathematics lecturer Puan Liu Wan Chun for giving this opportunity to present about the topic integration, and also for teaching us clearly and in detail. Hope this video is beneficial for you guys. Thank you.